Okay, now that we've looked at the basics of the Pythagorean theorem, we can start using it to tell us things about triangles. So this video is going to look at the Pythagorean inequality theorem. Now, I've left off the big wordy definition of this. If you want to look it up in your textbook, that's great. But I'm just leaving this in algebra terms. I think it looks pretty clear, so I didn't feel like we needed to write down the whole definition. But it's simply this. If c squared is less than a squared plus b squared, then the triangle ABC is acute. Okay? Notice that this is almost exactly the Pythagorean theorem, except we have an inequality instead of an equality. C is our longest side. A and B are our two shortest sides. Very important. That's the only way this works, is if we get the numbers plugged in correctly. C has to be our largest. A and B have to be the two smallest. So, if that's true, we get an acute triangle, something that looks like this. All right? Then, if c squared turns out to be greater than the sum of these two squares, then the triangle is obtuse, or something like this. Obviously, I didn't state it here, but if c squared equals a squared plus b squared, then we have a right triangle. Okay, that was a given from the couple videos we've gone through, the problems you've already worked. All right, so let's look at what this looks like when we work our problems. All right, we want to determine whether each set of numbers can be the measurements of the sides of a triangle. And if so, can we classify it as acute, right, or obtuse? So, two-step problem here. The first thing is it's going to give us three measurements. We need to determine whether this can even be a triangle. We worked on this early January a little bit. We looked at, can three measurements even work out to be a triangle? For that to be true, the two smallest sides, when we added them together, had to be greater than the third side. So in this case, it's true. 10 plus 11 is 21, and that is greater than 13. So we know that this can be a triangle. Okay, that was called the triangle inequality theorem. So, now we can do the test, since we know it can be a triangle, to see if it's acute, right, or obtuse. So, 10 squared plus 11 squared, we're going to see what that looks like compared to 13 squared. Okay, so 10 squared is 100. Plus 11 squared is 121, and we compare that to 13 squared, which is 169. So 100 plus 121 is 221. Compared to 169, we see that the sum of those is greater than 169. Since those two are greater than the square of this, we know that it is acute. So this is an acute triangle. Okay, again, if the sum of these two is greater than the square of the third, it's acute. Let's look at a couple more. All right, 9, 12, and 15. So look at the two smallest sides, 9 and 12. Add them together, we get 21. Is 21 greater than 15? Yes, so we have a triangle. Now we need to do the test using the Pythagorean inequality theorem to see if it's acute, right, or obtuse. So, 9 squared plus 12 squared, we're going to compare that to 15 squared. 9 squared is 81, 12 squared is 144, and 15 squared, I believe, is 225. Didn't work these out ahead of time. So, 81 plus 144 is going to give us, let's see, 225. Well, in this case, those are equal. Since they're equal, we have a right triangle. All right? So there's one. It turned out they're the same. We get a right. Let's look at this last one, 6, 13, and 19. Always do the test to see whether it's an actual triangle first. Well, in this case, your two smallest measurements are 6 and 13. Add them together, we get 19. Is 19 greater than 19? No. So in this case, not a triangle. There's no point of doing the test for acute, obtuse, and right if it's not even a triangle in the first place. Okay, work the practice problems, and we'll see you in the next video.